Back sponsors, parents, and supporters to the Auburn University Formula SAE Podcast Update. My name is Payson Williams, and I will be talking with team members about the design process, design goals, and talk about what's going on in the shop. Today we will be having a special carbon fiber topic discussion. Joining us will be Drew Campbell, Michael Moritz, and Ryan Reeves.
Hi, I'm Drew, the monocoque designer for the 2016 season. Specifically, I work on designing, manufacturing, testing of the monocoque. In design, we use HyperWorks, and then that's quickly backed up with physical testing to make sure our HyperWorks model is accurate. In manufacturing, we're exploring different types of manufacturing techniques that aren't necessarily mainstream. And then testing, that's all done when the car is ready for race, just making sure it's our measurement for how our design is. For physical testing, after we've finished the whole car, we use torsional stiffness tests to basically validate how good we were in design and see how all of our physical testing turned out with the full car.
Are we using the same monocoque mold for 2016?
Yes, for the 2016 car, we will be using the same monocoque mold as the 2014 and 2015 car, though it will be a different layup structure.
What gives our monocoque structural integrity?
So in composites, the strength of the structure that you're designing comes from the plies of carbon, but the rigidity, for the most part, comes from the core that you use. So we use a ply-based design in our monocoque.
And what is core?
So core is a structure that is used to basically separate the two plies of carbon on either side and increase the moment of inertia of that specific material, which will increase our stiffness.
What's the advantages to using a monocoque over a steel space frame?
So we use a monocoque instead of a space frame because the carbon in the monocoque has a volume to strength ratio that is very similar to steel, but the density of carbon is significantly less. So we were able to design a monocoque hybrid chassis that is between 15 to 20 pounds lighter than an equally stiff steel space frame would be.
I'd like to introduce Ryan Reeves of the aero subdivision on the chassis team.
Hey, my name's Ryan, and I'm on the aero subdivision of the chassis division. My main research goals is to develop the way to fabricate the aero package on the car. My design goal is to create the methods of fabricating the aero package and having the aero package be the lightest it can be and have the best surface finish.
What considerations have you taken for your manufacturing methods?
Because I'm able to focus completely on the fabrication methods, I'm able to look into less standard methods and really look at every possibility to create the best aero package I can.
Thanks, Ryan, for stopping by. Next up is Captain Downforce himself, Michael Moritz, here to talk about the greater technologies that Auburn University is implementing for our team.
Hey everybody. So Payson brought me on here today just to sort of highlight the fact that the Formula team at Auburn is one of the few programs on campus that uses modern day materials like carbon fiber and fiberglass and things like that. There's dozens of engineering programs on Auburn's campus, both curricular and extracurricular, but we're one of the only ones that uses the materials and does both design and fabrication of those materials to the extent that we do. This is significant that there are people that graduate from our team who make a career out of composite materials and or choose to study them in graduate school. Our chief chassis engineer from last year, Jordan French, is a PhD student at the University of Utah now, studying composite-related design. So we really pride ourselves on the fact that our program pushes the limits of the technology for our own gain, but also when people leave here, they are better engineers because of it, because of their exposure to that material. And it's not just one specific type or one specific set or one specific type of design. If you look at our car, there's both structural and non-structural uses of the material, and there's pre-preg carbon fibers, and there's dry carbon fibers that we put resin into, and there's unidirectional fibers and woven fibers and dozens of different types of material and uses for the material. And we're continuing to push those boundaries, and our car and our team and our people are going to be better because of it.
What are the main advantages of carbon fiber?
So one of the reasons that we rely on it so heavily is because of its strength to weight ratio. Per volume, it has similar strength characteristics to steel, but it's roughly a quarter of the weight. So a lot of teams use steel tube frames for their chassis, and we use a little bit of a steel tube frame, but our chassis is primarily a very lightweight and strong and safe monocoque. On top of that, a lot of teams have aluminum or heavy ABS plastic 3D printed intakes where we choose to make a carbon intake because of its weight and because it's a non-structural member, so it can be as light as you can dream it in all reality. And then again with wings this year, as opposed to using a material even like a heavier fiberglass or a thin light aluminum, carbon is even lighter, and wings in the rear especially are high up from the center of gravity of our car, and so we're trying to limit the weight that our car has in its outer extremities so that we can maximize our downforce but keep the effect that it has on the car in a negative way to a minimum.
Thanks, guys, for stopping by, and thank you for listening in.